Okay, so question 48, which of the following conformers of isobutyl chloride is the most stable? So the book gives you three different Newman projections, and so basically all you have to do is figure out which projection has the most, steric strain. So we're going to have Gauss interactions, and the more intense Gauss interactions that are going to be destabilizing are going to occur between groups that are larger or take up more three-dimensional space. So basically, the more steric clash, the least stable. The Newman projection that has the minimum amount of steric clash between very large groups is going to be the most stable. Okay, so we'll go ahead and talk about the most intense kind of steric clash that we see among all three of these, which is going to be chlorine to methyl. So chlorine versus methyl, both of these are relatively large groups, and so you're going to have a very destabilizing kind of interaction right here. The next kind of interaction that you could potentially have would be between, let's say, methyl and a hydrogen, or maybe, let's say, chlorine and a hydrogen. These are not too bad. These are still a little bit destabilizing, but there's not really much you can do to get around them. And so then finally, you'll have this kind of hydrogen to hydrogen interaction, which is basically nothing. So we'll have two more of these little minor interactions, or medium interactions. And so we'll compare and contrast this Newman projection with these other two guys. So we already said that the most destabilization energy is going to come between um, Gauss interaction between a methyl and a chlorine. So in this second, we're going to have two of these, right here and right here. And we're also going to have a few of these medium size type Gauss interactions between this hydrogen methyl and this hydrogen methyl right there. Okay, and then we finally have two very not very intense Gauss interactions between these hydrogens right here and these two hydrogens right there. Okay, and so then let's talk about this final and third molecule Newman projection on the right. So we have this very minimum Gauss interaction that's destabilizing here. Again, this is probably the best you could ever do, hydrogen to hydrogen. And then the next thing we have is a methyl to hydrogen, so that's a little bit worse, not too terribly bad though. Methyl to hydrogen and methyl to hydrogen right here. And then we also have, again, two chlorine to methyls. So we've got chlorine to methyl here, and chlorine to methyl here. So what we really have is, if you look at the two Newman projection farthest to the right, this Newman projection in the middle and this Newman projection on the right are actually the same exact Newman projection. All you'd have to do is take this molecule in the middle and rotate it just a tiny little bit, and you'd have the exact same molecule, which all of these are the exact same molecule, but you don't even need to rotate this carbon to carbon bond. Okay, so basically these two are the same in energy, and if you compare how many red arrows you have on these two versus how many red arrows you have on this guy, you really only have one relatively bad interaction in this case. So overall, these two guys on the right are going to be pretty unstable, and the molecule on the left is definitely going to be way more stable than the other two in terms of Gauss or destabilizing Gauss interactions. So the answer to this one is going to be most stable on the left. So this guy is going to be the most stable, and these two on the right are of equal stability. And they're also less stable. Okay, that's that.